Our solar system is a vast and mysterious place. Among these wonders, Saturn's rings stand out as a breathtaking spectacle. Orbiting this gas giant is a collection of over 80 moons, each with its own story to tell. These moons range in size from small, icy bodies to Titan, a moon larger than the planet Mercury. In this vast cosmic ballet, one moon stands out as particularly intriguing: Hyperion. Discovered in 1848 by William Cranch Bond, Hyperion is a small, irregularly shaped moon. Unlike most moons, which are tidally locked to their planets, Hyperion tumbles chaotically through space. Its rotation is unpredictable, making it a fascinating subject for astronomers. Hyperion's strange behavior and unique characteristics make it a captivating target for scientific study. By studying Hyperion, we gain insights into the complex processes that govern our solar system. Its unusual properties challenge our understanding of how moons form and evolve. Hyperion is an enigma wrapped in a cosmic mystery. Unlike most moons, which tend towards spherical shapes under the influence of gravity, Hyperion resembles a giant sponge, riddled with deep craters and sporting an irregular, almost chaotic form. This bizarre shape is one of Hyperion's most striking features. Its surface is a jumble of ridges, valleys, and cliffs, all seemingly randomly placed. This lack of symmetry is a testament to the moon's turbulent past. The most widely accepted theory for Hyperion's peculiar shape is that it's a remnant of a much larger body. Hyperion's surface is a testament to its violent past. Craters of all shapes and sizes dominate the landscape. Some are fresh and well-defined, while others are old and eroded, their edges softened by time and countless micrometeorite impacts. Unlike craters on other celestial bodies, which tend to be bowl-shaped, many of Hyperion's craters are unusually deep and narrow. This suggests that the impacts that created them were powerful enough to compress the moon's porous surface, leaving behind deep, scar-like gouges. The moon's coloration is also a source of fascination. While most of Hyperion is covered in a dark, reddish-brown material thought to be composed of organic compounds, there are also patches of brighter, more reflective material scattered across its surface. This suggests that Hyperion's composition is far from uniform. While Hyperion's surface has been extensively studied through images captured by spacecraft like Cassini, its internal composition remains somewhat of a mystery. One of the most striking things about Hyperion is its remarkably low density. It's one of the least dense objects in the solar system, with a density less than that of water. This suggests that Hyperion is not a solid, rocky body like our own moon, but is instead a loosely bound collection of ice and rock, more akin to a giant rubble pile than a solid sphere. Scientists believe that Hyperion's interior is likely a mixture of water ice, rock, and possibly other volatile compounds, such as methane and ammonia. The exact proportions of these materials are unknown, but the low density of the moon suggests that ice must be a major constituent. Hyperion's remarkably low density is one of its defining characteristics. To put Hyperion's density into perspective, consider that water has a density of 1 gram per cubic centimeter. Hyperion's density is estimated to be around 0.55 grams per cubic centimeter. This means that if you could somehow find a giant bathtub large enough to hold Hyperion, the moon would actually float. Instead, it's more like a giant cosmic sponge, riddled with voids and spaces. Hyperion's strangeness isn't confined to its sponge-like appearance and low density. Its journey around Saturn is just as peculiar, defying the elegant, predictable orbits we often associate with celestial objects. Instead of tracing a smooth elliptical path, Hyperion careens around Saturn in a chaotic dance, its orbit subject to constant, unpredictable wobbles and deviations. Its orbit is highly eccentric, meaning it's far from circular, and it's also significantly tilted compared to Saturn's equatorial plane. These factors, combined with the gravitational influence of other moons, particularly the massive Titan, contribute to Hyperion's chaotic dance. This chaotic orbit means that Hyperion's distance from Saturn is constantly changing. At times it's relatively close to the ringed giant, while at other times it swings far out into the depths of space. This fluctuating distance also means that the gravitational forces acting upon Hyperion are constantly in flux, further contributing to its unpredictable motion. While Hyperion's erratic orbit is certainly unusual, it's the Moon's chaotic rotation that truly sets it apart in the cosmic ballet. Imagine a top spinning wildly, its axis of rotation constantly shifting and wobbling, never settling into a predictable pattern. Most moons, including our own, are tidally locked to their planets. This means that their rotation period is synchronized with their orbital period, resulting in the same face of the Moon always pointing towards the planet. However, Hyperion refuses to conform to this celestial norm. Its irregular shape and eccentric orbit, combined with the gravitational influence of nearby moons, particularly Titan, prevent it from settling into a stable, synchronous rotation. Instead, Hyperion tumbles chaotically, its orientation in space constantly shifting. In the cosmic ballet of Saturn's moons, Hyperion is caught in a gravitational tug-of-war. While Saturn's immense gravity is the dominant force orchestrating Hyperion's overall motion, the gravitational influence of other moons, particularly the massive Titan, plays a significant role in driving Hyperion's chaotic dance. Titan, Saturn's largest moon, is a gravitational giant compared to the much smaller Hyperion. As Titan orbits Saturn, its gravity exerts a powerful pull on Hyperion, disrupting its orbit and preventing it from settling into a stable, predictable path. This gravitational tug-of-war is a key factor contributing to Hyperion's eccentric and chaotic orbit. The complex interplay between Saturn's gravity, Titan's gravitational influence, and Hyperion's own irregular shape and eccentric orbit creates a fascinating example of celestial mechanics in action. Hyperion's chaotic dance, while perplexing, is far from random. By studying Hyperion's erratic orbit and rotation, scientists can gain valuable insights into these fundamental forces and their influence on the dynamics of celestial objects. Hyperion serves as a natural laboratory for studying chaotic systems. These are systems that are highly sensitive to initial conditions, where even small variations can lead to dramatically different outcomes over time. Moreover, Hyperion's porous nature and low density, combined with its chaotic rotation, make it a particularly intriguing target for studying the effects of impacts on small bodies. By analyzing the distribution and characteristics of these craters, scientists can learn about the frequency and intensity of impacts in the early solar system. In the annals of space exploration, there are encounters that capture the imagination, moments when our robotic emissaries provide us with glimpses into the unknown. Such an encounter occurred in the fall of 2005, when the Cassini spacecraft had its first close encounter with Hyperion, Saturn's enigmatic moon. Imagine a spacecraft hurtling through the vastness of space, its instruments trained on a celestial object unlike any other. That was Cassini on September 26, 2005, as it approached Hyperion, its cameras and sensors poised to unlock the secrets of this cosmic oddball. As Cassini drew closer, Hyperion's bizarre sponge-like shape came into sharper focus. The moon's heavily cratered surface, a testament to its violent past, filled the spacecraft's field of view. Cassini's cameras captured images of unprecedented detail, revealing the intricate textures and subtle color variations of Hyperion's alien landscape. Cassini was more than just a camera in space. It was a sophisticated robotic laboratory, equipped with an array of instruments designed to probe the depths of Saturn's system. During its encounters with Hyperion, Cassini's instruments sprang to life, analyzing the moon's composition, mapping its surface, and studying its interactions with Saturn's magnetosphere. One of Cassini's key instruments was its visible and infrared mapping spectrometer, or VIMS. VIMS analyzed the light reflected from Hyperion's surface, allowing scientists to determine the composition of the moon's surface materials. The data revealed that Hyperion's surface is dominated by water ice, a common constituent of outer solar system objects. Cassini's images of Hyperion's surface provided a stunning visual record of the moon's violent past. The moon's surface is dominated by craters of all sizes, a testament to its long history of bombardment by asteroids, comets, and other space debris. Unlike craters on other celestial bodies, which tend to be bowl-shaped, many of Hyperion's craters are unusually deep and narrow. This suggests that the impacts that created them were powerful enough to compress the moon's porous surface, leaving behind deep, scar-like gouges. The distribution of craters on Hyperion's surface provides clues about the Moon's history and the processes that have shaped its surface over billions of years. Section 4. The Mystery of the Dark Material. Clues to Hyperion's origins. One of the most striking features of Hyperion is the presence of dark reddish material on its surface. This material is not uniformly distributed, but appears in patches, often concentrated within craters and other depressions. The origin and composition of this dark material have been the subject of much speculation and scientific inquiry. Cassini's instruments provided some tantalizing clues about the nature of this mysterious material. Spectroscopic analysis suggests that it may be rich in organic compounds, similar to the material found on other dark objects in the outer solar system, such as comets and some asteroids. One theory is that this dark material originated in the outer solar system, perhaps delivered to Hyperion by impacting comets or asteroids. Over time, this material may have been darkened by exposure to radiation from the Sun, a process known as space weathering. Another possibility is that the dark material is native to Hyperion, formed through chemical reactions within the Moon's icy surface, or perhaps originating from its interior. Hyperion's low density and porous nature suggests that its interior may be relatively warm, potentially providing conditions conducive to the formation of complex organic molecules. Section 5. Looking ahead. Unanswered questions and future exploration of Hyperion. Cassini's mission to Saturn was a resounding success, providing a wealth of data. However, Cassini's observations raised as many questions as they answered. Hyperion remains a compelling target for future exploration. One key question is the nature of its interior. Its low density suggests a porous, ice-rich composition. Future missions could use radar to probe beneath Hyperion's surface. Another area of interest is Hyperion's chaotic rotation. Gravitational interactions with Titan play a key role. A dedicated mission could study its rotation and map its gravitational field. The dark material on Hyperion's surface remains a mystery. Future missions could collect samples to analyze in Earth-based labs. Hyperion, with its strange appearance and chaotic demeanor, might appear to be an outlier, a cosmic oddity with little relevance to the broader story of our solar system. But appearances can be deceiving. Hyperion, in its own unique way, holds valuable clues to the processes that govern moon formation, not just around Saturn, but potentially around gas giants throughout the cosmos. Imagine the early solar system, a chaotic swirl of gas and dust surrounding our nascent sun. Within this protoplanetary disk, planets were beginning to coalesce, drawing in surrounding material and carving out their own domains. Around these young gas giants, smaller disks of leftover material swirled, the birthplaces of moons. Hyperion's low density and porous nature suggest that it may have formed through a relatively gentle process of accretion, where small particles gradually clump together over time. This is in contrast to the more violent impacts that likely formed some of the larger moons in the solar system. Studying Hyperion's composition and structure could provide insights into the conditions that prevailed in the early Saturnian system, shedding light on the types of materials that were present and the processes that governed their assembly into moons. Hyperion's chaotic rotation, a product of its irregular shape and the gravitational tug-of-war between Saturn and Titan, offers a unique window into the complex dynamics of planetary systems. While we often think of orbits as being stable and predictable, Hyperion's chaotic dance reminds us that even within the seemingly ordered realm of celestial mechanics, chaos can reign. Understanding chaotic systems is a major challenge in physics and astronomy. These systems are highly sensitive to initial conditions, meaning that even small variations can lead to dramatically different outcomes over time. This makes predicting their long-term behavior extremely difficult. Hyperion's chaotic rotation serves as a natural laboratory for studying chaos in action. By modeling Hyperion's motion and the forces acting upon it, scientists can refine our understanding of chaotic systems and their behavior. These insights can then be applied to other chaotic systems in astronomy, such as the orbits of planets in binary star systems or the dynamics of asteroids in the asteroid belt. Section 3. Small moons, big impacts. Lessons in solar system evolution. Hyperion's heavily cratered surface, a testament to its long history of bombardment by space debris, provides a valuable record of the impact history of the outer solar system. While impacts are a constant threat to celestial bodies, their frequency and intensity have varied over the history of our solar system. By studying the distribution and characteristics of craters on Hyperion's surface, scientists can learn about the population of impactors in the early solar system, their sizes, and their velocities. This information can then be used to model the evolution of the solar system and the processes that shape the planets and moons we see today. Moreover, Hyperion's small size and low gravity make it particularly susceptible to the effects of impacts. Unlike larger bodies, which can absorb the energy of impacts more readily, impacts on Hyperion can have a more dramatic effect, potentially excavating large amounts of material and even altering the moon's rotation or orbit. Studying these impact features can provide insights into the physics of high-velocity impacts and their effects on small bodies. Section 4. Beyond Hyperion. The broader significance of studying irregular moons. Hyperion, for all its peculiarities, is not alone in the universe. Astronomers have discovered numerous irregular moons orbiting other planets in our solar system and beyond. These moons, often small and irregularly shaped, are thought to be remnants of larger bodies that were shattered by impacts or torn apart by gravitational forces. Studying Hyperion and other irregular moons provides a broader perspective on the processes that have shaped our solar system and planetary systems in general. These moons, often overlooked in favor of their larger, more well-behaved counterparts, hold valuable clues to the chaotic early history of our cosmic neighborhood. Moreover, the study of irregular moons like Hyperion reminds us that our solar system is a dynamic and evolving place, shaped by a complex interplay of gravitational forces, collisions, and other processes. By continuing to explore these celestial oddballs, we gain a deeper appreciation for the intricate workings of our cosmic home and the forces that have shaped its destiny. Section 1. Hyperion's Enduring Allure, a cosmic puzzle awaiting further exploration. As we conclude our journey through the strange and captivating world of Hyperion, we find ourselves standing at the precipice of even greater mysteries. This cosmic sponge, tumbling erratically around Saturn, has challenged our assumptions about how moons form and behave. It serves as a stark reminder that our solar system is a place of endless wonder, where even seemingly insignificant objects can hold profound secrets. Hyperion's chaotic dance, its porous, sponge-like structure, and its dark, enigmatic surface all hint at a complex and violent past, a story etched in ice and rock over billions of years. Each new discovery about Hyperion has only deepened our fascination with this celestial oddball, raising more questions than answers. We now know that Hyperion is not just a random collection of debris, but a world shaped by a unique set of circumstances. Its chaotic rotation, driven by the gravitational tug-of-war between Saturn and Titan, its low density, potentially a result of gentle accretion in the early solar system, and its dark surface material, hinting at connections to comets or perhaps internal processes, all point to a history as intriguing as its present state. Section 2. A Universe of Mysteries, Hyperion's Place in the Grand Tapestry of Space. While Hyperion continues to captivate our imagination, it's important to remember that this enigmatic moon is just one piece in the grand tapestry of the cosmos. Its story, while unique, is interwoven with the stories of countless other celestial objects, each contributing to our understanding of the universe and our place within it. By studying objects like Hyperion, we gain a broader perspective on the processes that govern the formation and evolution of planetary systems. We learn about the diversity of worlds that exist beyond our own and the intricate interplay of forces that shape their destinies. Hyperion's chaotic nature, far from diminishing its significance, actually enhances it. It serves as a reminder that the universe is a place of constant change and surprise, a realm where chaos and order are often intertwined. It challenges us to expand our understanding of what is possible and to embrace the unknown with a sense of wonder and curiosity. As we continue to explore our cosmic neighborhood, we can be sure that Hyperion, that enigmatic sponge in the Saturnian system, will continue to inspire new questions and challenge our assumptions. And in doing so, it will undoubtedly lead us to a deeper appreciation for the beauty, complexity, and sheer strangeness of the universe we inhabit.